stage is yours.
Thank you. So, hello guys. Today I'm going to be talking about the fantastic 60 frames per second and where to find them. And so my name is Margarita. I'm a front-end developer at Futurize. And probably that's all you need to know about me at this point. So why did I choose to talk about the web animations? Well, first of all, they're quite necessary nowadays in the modern interfaces. And why? Well, and here I have to tell a disclaimer. If done right, they provide the storytelling and fun way to convey any message. If done right, they are very interactive and intuitive and add that extra delight feeling to the user experience when they browse your application. If done right, they provide the visual feedback and micro interactions as you can see in the image in the slide. And if done right, an animated design is a living thing. It's something that is going to give it a wow effect. It's something that is going to be remembered by the user and might even attract him or her to come back again and visit your website because, I mean, it's so awesome. You have animations on your website, right? So what's that FPS thing and why do we talk about it? Well, there is many ways to do the web animations, and most of the time what happens is that the designer gives you the frames, and as a developer, and I assume that most of you are somehow JavaScript developers here, you have to figure it out yourself. You have to somehow think, okay, what's the animation that I have to choose for this effect? How do I change to the next screen and what happens? And then you have a few tools in your disposal, which are either CSS, that are transitions and animations, or JS, which is set interval or request animation frame. And we're going to be pretty much just talking about those at this point. But before I'll talk about them, I believe there is this notion in the community that if you can make something with CSS, better do it with CSS. Don't really put it on the JS rails. So here I'm going to try to dispel that notion. I'm going to try to tell that, no, there is actually a few right ways to do the animations, and each case is really very individual. And before we do that, we're going to discuss two crucial things that you need to know before you understand how animations work, and they are critical rendering path and FPS. And I'm going to start with an easy part. It's the FPS. FPS is the frame per second ratio. So basically, imagine you are taking pictures with the Polaroid, and then you want to make it into a movie. So you're just going to flip 24 pictures per second, and bam, you have this illusion of the motion in your movie, right? So that's pretty much the same. Browser behind the scenes is drawing pictures when you're scrolling the websites, and it's drawing images to you, and that's how you see different parts of the websites, and they are also called frames. And ideally, you're going to see 60 frames per second. So ideally, browser should have 16.7 milliseconds to draw a new frame to you and show it to you. And in case if you're really overloading the browser, it's going to have a hard time to do that. So let's dive a little bit deeper into that and see why. This is a very simplified picture of a critical rendering path. And now I just realized it's very hard for you to see because there is white text in here. But let's imagine you have the DOM tree here, and you have your CSS file here. Are you following? Right? I'm sorry, guys. Basically, what happens is that they get merged together to create a rendering tree, which basically is your DOM tree in the end with styles. At this stage, it's called layout stage. What your browser is going to do is going to define the exact positions of each element in the page. So it's going to calculate, okay, these elements are this height, this width, they are at this point of the page. After that, it's actually going to show something to you. So now we're coming to the paint stage, where it's actually showing you the picture. So it's painting the layers to you. And the last stage of it is the composite layer. Composite layer is, well, when pretty much everything is painted, and you can do very little to it. You can just interact with the page and see some transitions. And why it's important to understand that? It's because A lot of people do animations the right way when they're triggering the layout, which triggers the paint, which triggers it to repaint the page, and that's how we have this problem with the frames. It has to repaint the frames at a very fast rate, and that's how we get the problem with the CSS transitions. So let's dive a little bit deeper into that again. Now it's a little bit of a demo time so that you understand better what I'm talking about. And we're gonna start with two websites that I randomly picked at the awards website, and we're just gonna see what the hell I'm talking about here. What is the FPS in actuality? As we can see, it's pretty nice website. It has all of these parallax transitions, a lot of very high resolution images. So yes, let's inspect it. And we're gonna go to the performance panel, and we're gonna enable something that's called FPS meter, which is frame per seconds meter. And here you're gonna see this very, very little box that gives you different numbers when you scroll on the page. So here I can see 32 frames per second, and as I scroll down it changes. So it's 32, 55, 44, depending on how fast I'm scrolling. So what it actually does, every time I'm scrolling, it redraws you a new frame, and it shows you how fast it does the redrawing. And if you can follow this thing, you can see it's kind of bumpy. It means that sometimes frames get very slow, sometimes frames get really fast. So those little bumps that you can see here is actually the drop and the raise in the frame ratio. You can also see that if we try to analyze it from the performance panel. So we're gonna now record our experience on the website and just try to scroll. And I guess 6 seconds is fine. Yes, so as you can see, we see this little green thingy, right? So this is what frames per second are. These are the frames that we have been drawing for the entire time we were on the website. And as you can see, it represents like this bumpy hill. So there is raises and there is falls, and basically usually when you see something like this, it means the website is not really optimized. It means that there is some animations that hold the drawing of the frames back. And that might lead you to the second point, which is like, so why should I really care about the animations then? Because they just hold the frames back and it just makes the user experience not so nice. Well, it's really up to you how well you optimize the things, because if we go to this website, it's much more sophisticated in terms of different animations. It has all the bells and whistles. It has this crazy animation effects, a lot of canvas videos, this micro interaction that I really love when you're trying to download an app. It just offers you two options. So usually a good frame ratio is anything from 30 up to 60. 60 is tops. 60 is like the best you can have. So guess how much is the frame ratio at this website? It's almost constantly 60. It's crazily well optimized in a way. It's working, and that's what I'm trying to showcase to you guys at this point. It's really about how you implement that. So let's go back to the presentation, and yes, as we can see, there is heavy animations and interactions, and not so much still different effects. So why is that? Well, usually when people do different animations, it looks something like this. So it's like bad code in a way. We trigger the transition, which affects the top property of the element, which means that the browser has to invoke the paint stage, which means that we have to redraw the entire image from the scratch, and of course it slows down the frame. And then you're going to ask me, how do I know if some property that I'm going to use in the transition is going to trigger the paint layer, right? So how can I know? Well, there is a very easy way to know with the website called CSS Triggers. basically here you can see most of the CSS properties and what kind of layer they trigger. So for example, here we can see that if we're gonna call the background position, it's gonna trigger all the layers. And yeah, so that's pretty much where you can check. So what should we do about it, right? That's the example of the animation done with this code. As you can see, it's a little bit of bumpy, and that's what it looks like on a performance chart. So that little green line that you saw before in the performance panel, that's what it represented here. And why it's doing this, because we have triggered the layout stage. So let's now analyze a very simple example of the app menu that is done with 3 elements, which is the layout, app menu, header, and menu icon, as in this animated GIF. So we want it to move like this. Inefficient CSS is going to trigger left, top, height, width, so those properties. And as we can see, we see a huge leap in the frame rate here. Better way to do it is to use transform, because then we don't have to repaint it all over again. We're actually interacting with the paint layer and the last layer. So now it's going to be much smoother from the user experience, and it's going to look much smoother from the performance chart here. Next thing, we can actually adapt it to the GPU, so to the graphical card. And this is actually one of the hack-ish magic properties I found out. Basically, will change property is something that's kind of very new, but it allows it allows browser to save it into the memory and make the graphical card do the calculations before it recalculates the frame. So if you do this, it means that it's going to do the calculations before we change the frame, and on the next frame it's going to be very, very small, as you can see here. But then we add JS, and that's pretty much in every project we have to create this button thingy that is going to trigger our app menu button, right? So we're going to add those layout, different styles, different classes, basically. I think it looks familiar to most of you. That's pretty much how you would do the menu, right? The problem is that we made the browser recalculate the styles again. So that's the normal transition. As you can see it, we take the initial point where the element was displayed and we just move it to the point, from the point X to the point Y, right? And there is a very interesting hackish solution for that. And I'm not going to promise you it's going to look beautiful, because we don't care about the beauty of the code here, we care about the performance. But this is a very interesting hack that you can do to make your animation smoother, which is called flip, which stands for first, last, invert, and play. And the flip is based on this method called getBoundingClient rectangle. So basically, this method is going to throw you something like this. It's going to throw you the information about the object in the layer stage. It's going to throw you the information about what the object was calculated to. So basically, we have this object in our layout, and it has properties of top, bottom, left, right, width, and height. So what can we do about it? Well, this gives us an opportunity to invert the transition. So basically, we're not going to calculate it from point A to point B. We're going to calculate it from point B to point A in a very interesting way. We're going to first move it to point B and then hide it to the point A. Then going to move it back again. And let's see where I'm going with this. First, the initial state of the element involved in the transition. So we're going to just get this element and get the initial state of it. So this top, bottom, width, height, all this information about it. Then we're going to get the last one. So we're going to add the class, remove the class, then add the class again. So basically, even before we have our page rendered, we're going to show it and hide it from the user already. and then get its new position. So why do we have to do that? What's the point of it? Well, that's the point of it. We invert it later. That's kind of the magic trick that we're doing here. We are calculating the difference between the first position and the last position, and we're also calculating the difference in size. And what we do with that is then we transform it when we actually need to show it to the user. So basically what happened is that we already moved it before the user even saw the page. And once we show the page to the user, we just transform it to the X amount of values. So we don't really have to recalculate it on the layer stage. We'll calculate it on the last stage when everything is already painted on the screen. And it doesn't trigger anything in the browser. And we're going to do it with the request animation frame. So once your script is going to be run, it's going to take the first animation frame before the page is even loaded. It's going to do all the calculations, and it's going to just trigger the animations when we have opened the page again and show it to the user. So that's something that our CSS is going to look like. So it's going to have nice transition transform, nothing too fancy in here really, and it's going to perform beautifully. It's going to be very smooth as butter, as you can see here on the screen. And you're going to tell me, well, that's a little bit of complicated, right? Like, we don't really want to write this much code and think about it. Well, luckily you don't have to, because this kind of human already did that. He already created a library called FlipJS that you can use and play with, and you can actually integrate all of that functionality into your website without really digging much. But I do suggest you to dig much because it's a very interesting topic. And yeah, that's one way to do it. And the good news is that everything is very compatible with SVG and Canvas. So basically, request animation frame, the transitions, you can pretty much do the same thing with Canvas and SVG. So yeah, go crazy, try to play with it with your favorite animation library. I personally fell in love with the Verlet.js. It's not actually a library, but something I really wanted to show you because it's web animation talk. It's the physics engine that allows you to do the crazy stuff. Something like this, using Canvas API, pure JS, very lightweight. So yeah, that would be my last point of the presentation. Try Verlet.js out. It's really kind of awesome. And yeah, thank you. Any questions? Yes.
Have you actually read the documentation for wheel change?
Sorry?
Wheel change.
Yes, it's advising you to use it with great caution because it might overload the GPU. Yes.
Worse performance.
Yes, so it actually, the MDN warns you that if you use it, please use it with caution. Use responsibly. Yes.
I think you should use it if you know that in, like, for example, 500 milliseconds you have something that is changing.
Yeah.
You tell the browser so that it.
Yeah, that's the point of it.
So you normally use it like from JavaScript. That's more likely than putting it in a CSS file, probably.
That's an interesting point.
Yeah, that's the same.
Yes?
Have you used the library called React Motion? Because there was like this Chinese guy or Asian guy who has made it, and he has a talk on YouTube, and it was so amazing, like animations done with JS.
I haven't actually, but now I think I should check it out.
Yeah, it was so amazing. I got like goosebumps too.
Really? Wow. Nice.
Yeah, check it out.
Thank you. Yes? Yes. Yeah, so basically whenever you're doing anything with JavaScript, let's say you're doing some set interval function, right? You are, first of all, you're triggering the usage of CPU. Secondly, let's say you're using, I don't know, timeout to change the color of a button, for example. What happens is that, first of all, it uses the CPU to trigger the animation, then it uses the CSS, the style layer, which triggers the layer function in the browser that then repaints it, that then puts it all the way back to you, and it's long. So what you want to do is to actually pre-calculate something before the next frame. So it's going to be very efficient in a way that it's just going to do anything for the next frame specifically. And you pretty much know that you have 60 frames maximum per second. So basically 1,000 divided by 60, that's how much milliseconds you get to do the calculations, and then you just can kind of calculate whatever set interval you need using the request animation frame. Any other questions? Okay. Thank you, I guess.